Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to KingCambridgeSolution.com. On this website, you will find the solution of past paper for Cambridge International AS and A level. On this website, you will find the solution of paper 1, paper 3, paper 5, and paper 4 for each question. The price for each paper is very economical, like 300 only for the one paper. So the main thing about the solution is step-by-step explanation of each question. Download the solution file in PDF and video format. And for contact, the WhatsApp number is 034542315525. The YouTube channel is my topper students, and the website is kingcambridgesolution.com. As a sample, I shall explain the question of paper 4. As you can see that in the question 4, Cambridge International AS and A level Mathematics 9709, paper 4, variant 2, session 2 bar number 2024. Question number 3. Let's start for the question number 3 of this question of this session. Question number 3 is a cyclist is riding along a straight horizontal road. The total mass of the cyclist is bicycle is 90 kg. The power exerted by the cyclist is 250 watt. At an instance when the cyclist speed is 5 meter per second, his acceleration is 0.1 meter per second scale. For part A, find the value of the constant resistance to the motion acting on the cyclist. For the part B, the cyclist comes to the bottom of a hill, inclined an angle 2 degrees to the horizontal. Given that the power and the resistance to the motion are unchanged, find the steady speed with which the cyclist could maintain when riding up the hill. So for the part A of this question, let's see the diagram on the screen. The data given is the mass is equal to 90 kg and the power exerted by the cyclist is equal to 250 watt. The velocity is 5 meter per second and acceleration is 0.1. By the Newton's second law of motion, F equal to ma, total net force. So m is equal to 90 and acceleration equal to 0.1. We get 9 Newton. So in this case, like the Fr is the resistance force, and as we have net force is Fd minus Fr equal to 9 Newton, as we have calculated in the above step. For the driving force, we know that power equal to Fd dot velocity. Driving forces, power is equal to F driving force dot velocity. By putting the value of the power and the velocity after simplification, we get Fd equal to 50. So put this value in the above step, we get Fd minus Fr equal to net force. Net force is equal to N and Fd is equal to 50. After simplification, we get resistance force equal to 41 Newton. So for the part B of this question, part B is given that the power and the resistance to the motion are unchanged. It means that the power and resistance remains the same. Find the steady speed with which the cyclist could maintain when riding up the hill. So let's start for the part B of this question. As you can see that the diagram on the screen, there are the different forces acting on the cyclist. Fd is the driving force, and in the backward direction there are the resistance force and the component of the weight mg sine 2 in the backward direction. So now the data is equal to theta equal to 2 degree, power is equal to 250 watt, resistance is equal to 41, mass is equal to 90 kg. Force acting along the hill is equal to Fd equal to, because Fd is in the upward direction and Fr and mg sine 2 is in the downward direction. So Fd equal to P over Y by putting the value of P and V. After simplification, now put this value of Fd in the above equation, we get in 1 we get Fd is equal to 50 over V, Fr is equal to 41. After simplification, we get 3.48 meter per second. So this is the steady velocity of the cyclist when moving upward, making an angle of 2 with the inclined plane. So see you in the next part of this session. Best of luck. See you again for the next session of Cambridge International.